My name is Shyam Kota. I'm the Director of Product Management here at Arista, looking at the EOS software. And today, in this session, I'm going to introduce you to Arista's cloud-grade routing. But before that, what's the motivation for cloud-grade routing, and how did we come to this space, and how is it addressing service provider challenges? And what are the service provider challenges? Today, we are in the middle of multiple transitions. There are, you talk to the customers, and there are so many new things that are coming out that it's pretty difficult to put all of them in a single place. So I kind of categorize them into three broad categories. One of them is the new edge, whether you want to call it the mobile edge or the IoT edge or the residential edge. Each one of these categories has its own set of transitions. If you look at residential, you have smart devices in the home, whether it is your personal devices or whether it is the devices that are monitoring the home or security, etc. The number of devices, the explosion of devices, is causing a transition right at the edge. And edge can be defined by the service providers in a variety of ways. There is metro, there is cable, there is residential, there is mobile, etc. But pretty much the challenge is the number of devices that are attaching to the edge are exploding in terms of numbers. The second is content. Content is king. The amount of consumption of content has pretty much skyrocketed over the last 2 years. And it is also driven by the richer media technologies that are behind the content creation. And there is content creation part of it, and there is content delivery part of it. There is uploads and downloads. The entire content landscape has changed as a result, and it's completely demanding more and more bandwidth for richer and richer media delivery, real time or otherwise. And then the third big transition is the distributed workforce. It's no longer the case where we are all happening to be in one office or one campus. The workforce itself has distributed. The collaboration tools have increased, and the number of interactions that are happening, like any-to-any format, pretty much is creating another transition. So these are all a wide variety of transitions that are clearly big opportunities for the service providers. However, in order to monetize these opportunities, you also have to tackle the challenges that you have, and service providers are clearly in the midst of a bigger transition themselves where they have to overcome these challenges. First and foremost, of course, they are under intense competition, whether it is the cloud or the OTT providers, that are coming after the service provider business. And then their revenue remains flat. There's a profitability challenges. But why is the case? That is because the CapEx spend that they are looking at in order to meet these transitions is really increasing. And that basically boils down to the architecture that they have standardized on and the accumulation of legacy that they have to keep spending in order to keep up with is one of the big items where the CapEx spend is continues to bog down. And the third one, of course, is the OpEx challenge. Based on the legacy install base and running the networks on the legacy, the OpEx continues to chew into the profitability. But then, in order to tackle the transition, you also have to have the newer models, newer operational models. DevOps, adoption of DevOps. The skill set that needs to cater to these operational models are something that also needs to change. And service provider challenges, if they're able to move forward, there's a huge amount of opportunity for them to tackle some of these exciting transitions that we are in midst in. So how is Arista's cloud-grade routing going to help some of these transitions? Of course, clearly, there are three big elements in this cloud-grade routing framework. The high-performance silicon, the scale-out architecture, and the glue to these two being the programmable software stack that is absolutely needed. So when it comes to the very first item, which is the high-performance silicon, The merchant silicon advances over the last decade has been leaps and bounds, and it is really delivering not only on the services but also on the performance. A service to performance curve usually is inverse of each other, but right now you have the advances of silicon that is able to cater to the bandwidth demand, the low latency applications or the services that it has to deliver. The progress of merchant silicon has been tremendous. And of course, in the next section, we will go more into the details of the silicon and the availability of merchant silicon, the applicability for the service providers. But the key here is that the continuous generational change in the silicon is actually bringing more bandwidth, more performance, and the reduction in the cost per bit when it comes to the previous generations. And that's phenomenal when you're building systems that are going to cater to the newer transitions. The second point about scale-out routing architecture. So far, we have been very much used to having the scale-up architecture, and this kind of catered to the yesteryear's requirements. But now suddenly you have these massive transitions for which you have to be very agile, and it's no longer the case where you are able to roll in the scale-up architectures and be able to deliver agile services. The architectures themselves have become rigid. But now with the ability to have a scale-out architecture, borrowing the page from the cloud networks, and the ability to quickly deploy capacity or newer services is a huge advantage. And the scale-out routing architecture really delivers on that point. With the silicon and the architecture, the glue here is the software. And the key to the software is a modern stack that can cater to the demands of the newer architectures. And primarily what I'm speaking about is the ability to cater to multiple profiles, whether it is the edge or the core, the ability to deliver new services quickly, the ability to react and have the visibility or the control of the network. All these are newer elements in the software stack that the network operating system now has to deliver. And one of the main things when you look at the operational profiles across multiple use cases is we are used to having different operating systems or different operating system profiles for different use cases. And that doesn't help the operational model, because now you're in a continuous loop of validation and deployment, and suddenly you have to go after a newer operating system model. But if you have the one operating system stack, a single OS that can be deployed across different deployment models, you now have a consistency of operation. And consistency of operation means you're increasing your operational efficiency. And the consistency can be brought about by the consistency in API, consistency in protocol, consistency in the automation framework, etc. And that tremendously helps in delivering on the silicon and the architecture and the operations. So these three principles of cloud-grade routing effectively can help transition the service providers to deploy multiple profiles and at the same time reduce the CapEx and increase OpEx efficiency, and of course reducing the OpEx spend as well. So what is Arista's story when it comes to these three key principles? What we have done is to build our Arista EOS operating system ground up, and that actually was the key advantage for us in the sense that we are able to look at the operating system requirements and the way we would like our customers to use the operating system. One of the main key attributes is being an open operating system, and open is probably a overused word, and open could mean open standards, open could mean I'm interoperable, open could mean I'm programmable, open could mean I can write my own code and run it as a process in the operating system, or it could also mean I can program the operating system or the silicon itself. Now, for us, for Arista, it's all of the above. we are completely open when it comes to providing the hooks into the operating system, right from external automation framework all the way to programming the silicon. We are able to provide that framework for customers who are looking to do it yourself, like the big high-scale cloud networks, or implement the DevOps models, or look at a turnkey solution. You have the choice of going down any of the paths, and you have the ability to use Arista EOS in any of the use cases. The second biggest attribute is resiliency. Operating systems have evolved over the years in multiple directions depending on where they are being used. But for networks, resiliency is key, because without the network connectivity, it's pretty much, your business comes to a stop. And the fundamental resiliency is coming from the architecture of the operating system. And for EOS, it's a pub/sub model. And the ability to, have the fault isolation, ability to have repairing the fault, restartability of the processes, is key to the resilient architecture of EOS. Now, we talked about the little bit about the architecture, but what about operations of the operating system? One of the fundamental shifts that Arista brought to the industry is not having to adopt SNMP, but having to go forward to the modern state streaming architecture. And state streaming architecture is really powerful because now the operators have the ability to get their information real time on the state of the device or the state of the network. And what is state? State is not configuration of the device or whatever is currently happening. State is the entire details, whether it is connectivity, whether it's the status of the transceiver, whether it's the protocols, the peers, everything that is happening in the device can collectively be streamed from Arista EOS to an external toolset. And in our case, we can also stream it to CloudVision, and CloudVision has the ability to get this state from the entire network and present you the whole network state in one dashboard. And that's very powerful because now you have the ability to understand what is happening in your network real time. Is there is a faulty transceiver, or is a cabling issue, or there is a issue with peering, and many such other fault conditions. And finally,
Nick, I've got a quick question here. I'm going to break in real quick. So you're talking about streaming the telemetry to the CloudVision system. Can you comment as to the scale that you can build to with that? Because a service provider network is often very, very large and geographically diverse just by nature. So if you can talk about like maybe number of nodes streaming the telemetry, what's the round trip time details for something that's, say, on the other side of the planet, anything that goes along with that, I think would be interesting and useful.
Yeah, thank you for that question. So if you look at the deployment models, if I take an example in the data center, you could probably have a data center pod with 50 racks, 100 nodes, probably 120 nodes, and each one of them is streaming this information to the central CloudVision engine. Now, when we are streaming the state, it's the very first time when the system comes up, the entire state is streamed. And then from there on, the incremental state is streamed into this engine. So what you see on the dashboard is the historical view of the entire state that your system or the network is currently having. Now, when you look at a service provider network, you have a similar topology. You have the provider edge and the provider core and the multiple nodes that are spread across geographically, and the ability to manage them. It could be out of band or in band, but let's take the case of an out of band, and you are able to stream this information out of band. You can have a central network operations center where you're receiving this streamed update. And in terms of the number of nodes, we could probably scale more than 1,000 nodes. And that means that you have a 1,000 node network that is sending you this real-time state information, and you have the capability to store this. And of course, the storage is something that one can plan, design and plan around, and that can store the historical data as well as accumulate the real-time state that is being streamed. Does that help your question?
How long can you store that historical data?
So you can store, it depends on the amount of storage you have, but typically you can go for 90 days, right?
Okay.
And that's about a quarter worth of, or 3 months worth of data that you can store, and then you can archive it, and then you can continue to, keep getting the next phase of data, right? So you can continue to keep this and then go back in time if you want to go back and do some analysis or investigation and things like that.
That's what I'm thinking, like from a capacity planning point of view. 3 months is great for when you're doing, tactical stuff. If you want to go back further, you're saying you can grab that, you can archive it, and then revisit it later. Okay, excellent. Thank you.
Absolutely. And the other interesting thing is, if you want to consume the raw data by using your own framework, you can do that. You can use third-party operations as well, which can consume this data, or you can use Cloud Vision. We give you the flexibility. It's not necessary that you have to use Cloud Vision. You can use this data in any form, but the important thing is that you're able to preserve that data for compliance purposes or for investigation or fingerprinting purposes, whatever is your requirement is.
So is it stored in a standard format then?
Yes.
Okay.
Yeah. That's correct. Yeah.
Thank you.
All right. And then, of course, the last point that I wanted to touch upon is the third-party integration, which is, of course, key when it comes to having the open network or open fabric, if you will. And this is important because now you have the ability to, it's important for the next generation architectures to be able to seamlessly integrate and have the ability to exchange information or, push the policies or, send the data that is needed. And this is all done through automation and API planes. And the ability to have that as built-in part of the Arista EOS is huge benefit for our customers. So this is something that many of our customers are also using in order to integrate some of their current tool sets as well. So from the software side, I'm jumping onto the routing stack. There is tremendous amount of investment that Arista has made, as Anshul spoke in the previous session. But the key here is that we are all about open standards. We are not putting any kind of proprietary fabric. We are not, having any proprietary solution. Everything here is standards-based, and our customers deploy this. They're able to deploy our systems in the existing brownfield environments, build newer deployments, knowing that these are all interoperable with the other vendors in the routing domain. And here, just as an example, you have multiple use cases, whether it is peering, whether it is DCI, whether it is the provider edge or the core. Multiple protocols that I have listed here are all pretty much open standards. And then so is the modern operations framework as well. Even that is completely standards-based. And the other interesting thing is that we completely give you access to the Linux that we have as part of the operating system architecture. You can actually look at, use the open source tools. You can actually go down to the Linux shell. You can use, open config models. So modernizing the operations starts with the operating system and the ability for the operating system to give you those tool sets and the environment. So that's kind of a snapshot of the operating system stack, and Alex is going to go more into the details here. And then, of course, the portfolio, which I alluded to on the merchant silicon, is, of course, starting from the fixed form factors, from 10 gig to 25 gig to 100 gig to 400 gig to modular form factors. The wide variety of operating system modular platforms is available for our customers to deploy in a variety of scenarios. And of course, now I talked about having the routing stack, the MPLS stack, segment routing, RSVP, traffic engineering, EVPN. this is yet another stack. How do I be assured that this is something that we can deploy in the network is the next obvious question. Of course, Arista has been participating in the industry interoperability event, which is run by EANTC, and this is our 5th year of participation this year in 2021. And there are a variety of scenarios where we have participated, whether it's EVPN or SRMPLS or TILFA based test cases. And in all of them, broadly categorizing them between MPLS and the data center EVPN test cases, we are the only vendor with our merchant silicon portfolio and the single OS binary that is running across the platforms to pass all these tests, whether it is VPWS or EVPN E3 or EVPN active. All these tests are, of course, available to you in the EANTC website. But this is just a snapshot for us to share with you on the breadth of tests and the maturity of our routing stack when it comes to interoperating with the existing environments. And finally, I'll leave you with this slide as to why are our customers adopting the cloud-grade routing. What is appealing about our story? Primarily, it's innovation. The ability for the customers to innovate, to take a fresh approach at the architecture, and ability to save on capex and opex. And here are 3 examples from the provider edge use case to Metro Ethernet edge use case. We have customers across geographies around the world. And the key is, of course, from Arista perspective, the cloud-grade routing is the future, whether you're deploying cloud scale networks or service provider scale networks, whether you're modernizing your edge or your core, this is the step forward. And we would like to participate and partner with you as we go forward in this journey.
I have a question. It's just a general question. So I was wondering why you call it cloud grade routing instead of carrier grade routing, because when we think about cloud, we think things can fail. When we think about carrier, we think it's carrier class. So it's just a general question.
It's a good question. The key to the term comes from the fact that we are applying the cloud principles, the architectures that cloud operators have built, and we have partnered with them and we have built the cloud scale networks. And the experiences and the maturity that our EOS operating system has come over the years is how we have evolved our routing stack as well. The cloud principles are key to the foundation of our routing stack. So that's why we call it cloud-grade routing.
And why don't you call it router instead of routing?
Because we are transforming routing. We are not building routers. That's the short answer. The key is that, we have come to a point in the industry where we shouldn't be really distinguishing between switch and router, but that's a debate for another time.